Okay, thanks for joining everybody. And what I want to do is just mainly talk about the exam that's coming up Thursday and Friday. So, what I'm going to do here is I am going to get a whiteboard, and hopefully you can see this. If at any point you're not hearing me, throw something in the chat. I'm assuming you can see this. I'm going to write and talk about the exam here. Let me get this pencil. Hopefully it'll work. Hold on one. Oh, you know what? Hold on a second here. There we go. Yeah, I don't think the pencil was connected. Okay, let's try that again. Here we go. There we go. All right. So hopefully you can see that, my scribble there. So we're talking about exam one. It's not coming up real well. Let's see here. Hopefully I can do better. Okay, come on. Okay. And the first thing I was going to mention is just the times again. I don't know why. Wow, this is not drawing very well. I think I had this trouble before. Changed it. Hold on. Let me change this here to a pen. I think I changed it to a pen and it worked better. Um, let's see. Let's try this. Yeah, except it's too thick. Sorry, guys. I'm trying to get this. I'm trying to do this on the iPad because I think it's better. But again, my apologies. Let me try this again on the pencil. Okay. All right. So I'll just have to be careful on this thing here. So we're talking about two times. Okay. We're talking about Thursday. Okay. Hold on. Sorry, guys. I am not the best with this and I'm still trying to work on this. Let's see here. I may have to do some different thing. So we've got, that's a little better, maybe. Not really. It's like I'm drawing, but it's not there. Some of it's not coming up. Okay, Thursday, I have the night option, which is going to be 7 to 10, 20. This is the worst. Hold on. I'm just going to use something different. Okay. No, hold on, guys. Let me do this. I beg your pardon here. I'm going to do this. I am going to go to a different app here to draw on. And I know I've got one on here. Here we go. And I'm going to, no. Here we go. Let's, because I did this before and it worked great, but this is terrible. So let me get this. Here we go. Okay. Yeah, there we go. All right. Now let's make a new one. What in the world? Come on. I am sorry. I need to do better at this. I used this once with someone else and it worked great, and now it's not working. Hold on, guys. I'm trying to get this set up so I can just draw something, and it's not working. So please, your patience as I continue to look at this. Oh, this is the one I wanted. I think this is better. Okay, let's try this. And now let's get rid of this. Okay. Uh, okay. No. Okay. My apologies, guys. I am trying to get this set up. I am I am trying to get this set up. It's not working. It's not working. Guys, just give me a moment. I'm going to get this. I'm right now I'm on an app where I'm trying to draw and it's got all sorts of stuff my kids have done and I'm trying to delete it. And so as soon as I can delete it, I will be able to, I think, share my screen and then work it. But I cannot, for the life of me, figure out how to delete it. Um, sorry, guys. Just give me a second here. I am. Oh, here it is. New sketch. How about that? Create. Discard current sketch. Discard. Okay. Is that going to be better? Let's see here. Okay. Let's try that. This is works. Nah, let's see here. Yeah, this works better. Oh, that works way better. Okay. Now, let's see if I can do this. And again, sorry, guys. This is thanks for all your patience here. I'm going to share my screen. Here we go. Okay. All right. So hopefully you all can see my screen. And what I'm going to do is go to here. And now hopefully you can see this. Type in the chat if you cannot see where it says exam. Oh, see, this is perfect. Exam 1. Okay, see, that's exactly what I want to show. And I don't know why the other app just sucks. So Thursday, 7 to 10:20 p.m. That's perfect. That's exactly how it should be. Friday, 1 to 4:20 p.m. Y'all see that? Just anybody said, yes, I can see where it says exam 1, Thursday, Friday. Y'all see that?
Yeah, I can see it.
Thank you. Thank you for chiming in. I appreciate that. Okay. So what I want to do is go over what's going to be on the exam, because obviously you already know this information. I've already given emails on that. These are the 2 times. You do not have to tell me which time you're attending. I don't care. Just show up and take the exam just like you took a quiz. Okay. We've had 3 quizzes, once today, just like that, just like it. You will be able to see all the questions at once, so you can jump back and forth. You will have 3 hours and 20 minutes, which is a huge amount of time. Okay, massive amount of time. And there will be 8 questions. Okay, so now what I want to do is I want to actually go over what to study. Okay, so now the basic principle, of course, is it's videos 1 to 12 and the homeworks 1 to 6. Okay, that's the basic principle there. Okay, the videos 1 to 12, homeworks 1 to 6. Now, I'm going to give you a little more though, okay? Because we're talking about 8 questions, I'm going to give you 8 topics. And for each topic, I'm going to tell you what homework that was covered in so that you can look over every topic and look over the homework, okay? For each of these 8 questions, okay? So I'm going to give you 8 topics. So, first topic is adding two-dimensional vectors, 2D vectors. That was in homework 1, okay? That should be a really easy problem. I'm going to be honest with you. In these 8 questions, I want to have at least 2 problems. My goal is to have 2 problems that are just super easy, okay? Just like, oh my goodness, if you get them wrong, you haven't been paying attention at all, okay? And by the way, yes, it's multiple choice. Just like the quiz, right? Just like the quiz. So it's going to look a lot like the quiz. All right, so adding 2D vectors. Another one is adding 3D vectors. We did that in homework 2. Now, a couple ways in which we could do this. One thing just to remember when it comes to adding 3D vectors is sometimes I might give you a vector that's between 2 points in space. Okay, so let's think of the classic example as a cable. A cable is connected between 2 different points and it's pulling, right? Because cables always pull. So how would that work is that you would have to say, there would be, let's say, 200 pounds of force in the cable between these 2 points in space. And you would have to figure out how to break those up into X, Y, and Z components or IJK components, right? And then you add up your IJK components to each other. So you might have like one force that is pure I, pure J, pure K, whatever, and then another one's on a cable and you have to add them up or something like that. Okay. So make sure you review how to um, how to get a force in IJK components based upon 2 points in space that the force is between. We did that in homework too. Okay. I've done that very clearly in the lectures. So you can go over that. Make sure you know how to do that. Um, Another one here is angle between the tail of two vectors. That one's pretty easy to do. And the nice thing is it's a nice, easy formula between tail of two vectors. We typically do that in 3D, by the way, but it's in chapter 2, sorry, homework 2. And so that one's pretty easy. There's a formula that is in the notes and also in the book, which just this all reminds me. Remember, it's open book and open notes, okay? Open book and notes. Now, here's the deal though, and we've talked about this before if you've been paying attention. Um, you're taking the quiz on the computer. So the computer is going to be locked in on just the test, right? So you have to have this somewhere else. You know what I'm saying? You got to have this book or these notes. Print all you want. Print tons of paper. Print all you want. Have whatever you got out there. Okay. And then you could look at that formula. Okay. Print all the notes or something so you have all the formulas. Okay. Um, that's something to consider. Print it all, so that you have all the formulas. I will, by the way, provide a formula sheet though. Okay. I will send everyone a formula sheet that you can use if you want to. But again, you don't have to because you got the book, you got the notes. But I know some of you rely on the computer for the book and the notes. And so, I don't know. I guess if you had another computer, but then the system that we use for the to keep you from cheating, it likes to look around and see other things. And so that's not a good idea because you could get flagged for cheating. So it's better to just have all the notes, everything printed out because you will never get flagged for cheating if you just have stuff printed out or the book or anything like that. Okay, another one. Another idea is 3D moments. That's using R cross F. And we did that in homework 4. That's a good topic to do. Basically, if I just gave you a force and it's IJK and I gave you an R, maybe the force is you have to figure out the force, get the IJKs, but then you've got, the distance from this point given as an R vector, and you have to do the cross product to solve for, and maybe I ask for the magnitude of the force, I'm sorry, the magnitude of the moment, you know, so that's a possibility. Review homework 4. Another one that's similar is possibly a moment about an axis. Now, and that one's we also did this in homework 4. That one's pretty simple because what you do to get a moment about an axis is you get the moment about a point on that axis, and then you dot it with a unit vector in the axis direction. So I'm going to keep this simple, I promise you. The axis is going to be X, Y, or Z. Okay. So all you're going to have to do is get the moment about like the origin, and then typical origin's good because the origin goes through X, Y, Z components, IJK. So if you get it about the origin and then you just dot it with, let's say, the I vector if it's in the X direction, or the J if I want the moment about the Y axis. So that's not a bad way of doing it. But review that. Another one that we just had a quiz on, and I'll talk about the quiz in a moment. Equivalent forces. Okay, homework 5. This is where I give you some forces, maybe a moment too, and I ask you to add them all up to one force, or maybe two components or whatever, but replace it with one force and give me the distance of that force from a certain point, just like what we had in the quiz. I know we had some questions in the quiz. I'll get to that in a moment. Also, distributed loading. And that is also in homework 5. I will not give you anything that involves calculus. Okay, I promise you. If there's a distributed load, it will only be rectangular and triangular loads, which is what I covered in the lecture. Nothing more than rectangular and triangular. That's it. It might be a combination of rectangular and triangular, but nothing else. Okay. And last one of the 8 is basically, I just call this a basic 2D equilibrium problem. The reason I call it that is that it's basically covered in homework 6. That's basically what we do in those. It was essentially just you've got a body, right? And you're going to draw a free body diagram and solve for forces, moments, or whatever. So, yes, can you mute your mic? Can you mute your mic? If you have a question, thank you. We'll go through this in a moment. Okay, so what I want to do for those of you, I've got that up now. I'll talk about the quiz in a moment if you have a question on the quiz, but I do want to ask if anyone, let's see here, does anyone have any questions? You can pop in on the chat. Let's see here. Let's see. Let me look at the chat. Let me look at the chat here because I didn't I thought the chat was going to come through here. Yeah, I think WebEx is bad. Okay, thank you guys. Okay. Yeah, the question about partial credit. Here's the thing on that. So far, with the first 2 quizzes, people have done pretty well. And I mean, what I mean by that is the averages have been pretty good. Obviously, with the quizzes, the average is 0. You either get a 0 or a 10, right? There's no partial credit. The averages have been pretty good. But the third quiz was not so good. Okay, and I'll talk about third quiz, and I might try to do something to help. We're gonna try this. If it stinks, then I'm gonna do on the final. I'm gonna collect everyone's finals and all that, and I'll hand grade it or something. Okay, it's just a lot of extra work to do all that in this kind of environment. Now, I would rather have everybody get together and we just take the test in person, like I've always done, but we can't do that. So it's just it's a mess. So we're gonna try this now. Let me just tell you this. I'm going to be 100% honest with you on this, okay? I make these tests easier than I have in the past, okay? This test you're going to take this Thursday or Friday, either one, is going to be easier than the tests I gave last summer and the summer before that and the summer before that. They're easier. I have to make it easier because I don't have partial credit. I'm trying to make these problems super easy and super straightforward, okay? Now, I hope you agree with me and you do well, okay? But I'm just telling you, I'm making the problems easier than I would normally do when I give a regular test but have partial credit. I'm making it easier to try to help people. So, but I agree that it's not easy. Yeah, you can use any calculator you want, by the way. That's not a problem at all. Any calculator. Okay, so is there any other questions with regard to the exam? Thought I heard somebody pop in. Somebody want to pop in with a question or no?
For the 3D moments, I had difficulty figuring out what the order of which ones to use, like when to use which vector to use for cross multiplication.
Oh, you mean R cross F, and what's the order to do them in? Like,
Yeah, I know it only just changed the sign of it, but it may depending on how the question is asked.
okay. Let's see here. Can I?
Professor,
Yes.
is there any way we can like redo quiz 3 or something like that to
Yeah, let me answer his question first, and then I'm going to talk about quiz 3 because there were a lot more problems on quiz 3 than I anticipated. So I'm thinking about just trying to offer something like that. But let me just talk about R cross F here, um, on this thing here, and this is where it gets back to how do I use this thing to scroll because it doesn't want to scroll. Okay, this is, let's see here. Do 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 do. I want to, and this is where I'm, okay. I want to add a page here. Is this it? No, I don't want to do that. I want to get another page. I think that would be like the easiest thing to do. Um, it just, that doesn't scroll. Okay. I need to get better with my tools, guys, and I'm sorry about that. And I was going to use that WebEx tool, but that was stinky. So I'm using this tool because it seems to be better. Let's see, does this do it? Okay. That doesn't do anything. I don't want that. Okay. I've got to get better at this thing. Okay, so I'll just try to answer it up here. I've got very limited space here, but let me just try to answer this the best I can. So when we're talking about R cross F, write anything. Okay, it's not even letting me write. Okay, so, okay, okay, okay. Now can I write? Oh my gosh, come on. Okay, it's not letting me write anything. Oh, what was that?
That's what I felt like on quiz 3.
Yeah, I'm sorry. I thought the quiz 3 was, honestly, I thought that was the easiest quiz ever. And I bet if you guys saw the solutions, but I think somehow it just got lost in translation. So let's see here. Okay.
Sounds like my quiz 1.
Yeah. Okay. So let's see here. Let me see if I can go back to, okay. Oh, these are just layers. That's what I'm doing. That's not doing it. Okay, I think there's like something up on top or, okay. What does that do? That doesn't seem to do anything. I don't know this app at all. Okay. All right, so this is not working. The key thing I'll say on R cross F, I mean, is that you've got to come up with your own way of doing the IJK. That's the thing. This thing is not even letting me draw anymore. I don't even know what I'm doing. So you got to come up with your own way to do IJK. And there's lots of different ways people have. Let me kick out of this thing. Let me see if I can do this. I'm gonna do this. I'm gonna stop sharing here, and I'm gonna try to kick on this regular thing here. Hold on. Let's see if I can get this stupid whiteboard to work again. No. Okay. So when it comes to R cross F, work. Get this to work. It's weird. It does tend to work a lot for this side. Yeah. It works big. When it comes to R cross F, um, you've got to have the key thing. This is the way I do it. You might do it differently, but you've got to have like an I, you got your J, and you got your K. You've got to have your rules and just know which is which. And I use the right hand rule. So I take my right hand and I grab the I and I turn it into the J. If I pull the I into the J, my thumb points positive K, which lets me know that I cross J, it's like it doesn't want to do a dot. It never does. Okay, here we go. Equals K. Okay, but then we know J cross I equals, well, if you go the other way, if you take your right hand with J and you go down to the I, it has to be negative K. The good news is when you're doing cross products, it's always the other letter. So if you're crossing two, I, J, J, I, it's always the last letter the remaining letter. You just don't know if it's positive or negative, and that's where I use the right-hand rule. So, for instance, what's K cross I? Well, K cross I, if I take K and move it in the I direction, I just get J, not negative J, just positive J. So anyway, but I think that's the key is you've just got to learn how to do those cross products every time, and just practice with that. And if you practice a few times, there's a lot of, by the way, the online homework system has this whole study area. There's a ton of stuff in the study area where you can look through practice problems and such. Also, if you've got any copy of the textbook, go through and do a problem and just do
Well,
the R cross F. Yeah, go ahead.
it's not so much that. It's just I know that you take the vector that points to where the force is acting upon.
Do you mean the definition of R? That's, I think, what you're asking. What's
Probably.
the definition of R? The definition
Which
of
one's which?
R, okay, the definition of R, because here's the thing. If I have, let's say here, of course, we'll see how well this goes. I think if I move slow, it's better. Okay, let's say I want to sum moments about this, let me see if I this point here. Okay, we're going to call this point A, and I'm going to have a vector, and we're going to call it this. Let's see if I can do it. Come on. Okay, this going to do it. There we go. We're going to call this a vector B. Okay. Now, the definition of the R vector, okay, the definition of the R vector, let me put it in this one, goes from A to any point on the line of action of B. So you always start at the point you want to sum moments about, right? If I want to sum the moments about A, right? If I want to sum the moments about A, I start from A and I go to any point on the line of action of the vector that I'm doing the moments about. So that can be the thing that maybe you get flipped around, because if you go the other way, then it's going to be negative. Yeah. You always start at the point you're summing moments about. So start at the point where you're summing moments, and then it's a vector that can go to any point on the line of action of that force.
And then
That's
we're also
R.
talking about the full length, not a unit vector. We're talking about the full length.
Oh yeah, not a
Yeah.
unit vector. No,
Yep.
the full length.
Absolutely.
The full length, not a unit vector. No, the full length. Yes, yes, yes. Yep. And the nice thing is you can choose any point on the force. The force can start from one point and go to another point, but you can choose any point you want that's on that line of that force. Now, typically it's really easy. You just pick a point that force goes through. But you can pick any point. But that's a good point. Yeah, because the only time we really use the unit vector, well, there's a couple times, but the two times I could think of right off the bat, we use unit vector. Early on, we used unit vectors because we want to describe a 3D vector between 2 points. Okay, I talked about that. It's like, what's a vector that goes between 2 points? Um, that's you use the unit vector, because if it's 2 points in space, those 2 points in space, the distance between those 2 points has nothing to do with how much force is in those on that, and so you have to divide it out. That's why we use a unit vector.
Like
The
a
other
fence being
reason,
pulled in the direction of a cable.
yeah, exactly like that. The other time we use it, a unit vector, is like, well, let's see here. We have like a vector projection. Like we do that, but that's rare. And in fact, it won't even be on the test. We could say, well, what's this projection of this force in this other direction? We would use a unit vector for that, but we won't even do that in this test. I've already gone over the topics, the 8 topics. So yeah, so that's it. All right, so let me do this before I answer any other questions. Let me talk about quiz 3, because I know that there were some issues with that, and I apologize. Let me see if I can. No, I don't want to talk about that. So let me do this. Not that. Let's see here. We'll go back to the whiteboard. So about quiz 3, yeah, that actually looks decent. I guess if I go really slow, it's kind of dumb. Okay, so you can't go fast. Okay, whatever. All right. So it definitely didn't go as well, and the averages were much lower. So I think what I'm I think what I'm gonna do is I'm just gonna reopen it. Like basically, I'm just gonna put it. I'm gonna run it again. Okay. And I'm gonna try to put an email out to just again describe what I want to do, which is exactly like the homework. Basically, every one of the problems in there did this. It was kind of like every one of the problems was pretty much the same. There was 4 different problems, so because I have different ones I give, but every one of them had like, okay, you got a vector like this. I'm just as an example. One of them looked like this. You got a vector like this, and this one was like this in one of the examples. This one was like 200 pounds, and this one was 100 pounds, right? And it had like a 60-degree angle, something like that. I can draw that. Okay, 60-degree angle, right? And it said replace these two forces with one force and give the distance from, I think in this case it was like the origin O or something like that, which there we go. I don't know why it doesn't draw, but whatever. Okay, the origin right there. There, that's better. Okay, so all you have to do, and every quiz was just like this. The first step one is just get the moment about O. Like look at the picture that you are given, okay, and just get the moments, sum the moments about. It might be O, it might be a different. Don't worry about the letter. The moments about O. So look at the picture and go, what are the moments about O given in the picture? Okay, that's step one. Step two, you go, okay, well, obviously I have to replace all these forces with one force. And so the way to do that, I recommend, is components. Basically, figure out what are all the x components, right? And what are all the y components, right? I always recommend components, 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 components. This whole class is all about components. Break everything up into X, Y, and Z. Always, always, all the time. Always, 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 always. Okay. So break it up into X and Y. So take that 100-pound force and break it up into X and Y. The 200-pound force was already pure X, negative X or whatever. Because I think in this problem, this is positive X here. I don't know why it doesn't want to do this. Okay. And this is positive Y. The problems were all different. Okay, so you break them up into X and Y, get all the components. This particular problem, if you read the description, I think I can't remember which ones. Some of them said put it on the x-axis, some of them said put it on the y-axis. So all you had to do is go, okay, where am I going to put this force? Because you're going to have basically in components, you're going to have a vertical component like that, and eventually you're going to have also going to have a horizontal component like this. Now you realize when you move it to the x-axis, the horizontal component doesn't matter. The only thing that matters is the vertical component. That's all that matters. That's the only component that's going to create moment. So then where's the point that you have to have? Well, it's the point you have to have this is step 3, if I can get this to come up. Okay, step 3 is to figure out this distance x, right, between O and where that vertical component has to be. And it's only the vertical because you moved the force to the x-axis. So the horizontal component goes straight through O. So you moved it, it's only the vertical. And then all you have to do is go, well, whatever that force is, I'll call it F, get it right here, Fy, right? Because it's only the vertical, right? I'll call Fy times X, that to draw, equals that moment that you already had before, right? The same moment that you already had before, right? So that's all you had to do. And then all you had to do is give that distance, which is exactly what you did in the homework. Because in the homework, it kind of said, okay, give me the magnitude, and then at the last step, it was like step C. It said, give me the distance from whatever point. And so that's exactly what you do on quiz 3. So
And if you
anyway,
calculate that about y, you would just do the same thing, but you would use
yes,
the horizontal.
exactly. If I asked you to put that on the y-axis, you would only be using the horizontal. Exactly. Yes. So, yep, that was it. So, what I probably will do is just throw it up again, and then I'll tell everybody, well, if you got a 10 out of 10, don't take it again. But if you got a 0, try it again. Odds are 1 in 4 you're going to get the exact same problem. But 75% chance that you get a new problem, and so you'll just do it with a new problem. So I think that's what I'll do. I'll just throw it up again. And maybe there was confusion. I did talk to some students that seemed to be confused. So I want to help out that, and we'll try it again. But because the test is tomorrow or Friday, I have to see. I have to think about when I do it. I mean, I guess I'll throw it up for I don't know, Thursday and Friday, and just whenever you want to do both, you just do both. So I'll probably do something like that and just come on in and try again on quiz 3. And honestly, there'll be a problem on the test that might be similar to this. It might be different. I mean, it's going to be a different problem. It won't be the same, but it might be similar where you have to take some combined forces, maybe moments, combine them up. And maybe this time I ask for the magnitude, or maybe I give you a different type of problem. I don't know, but it's similar concept. So. Okay, so I've gone over that. Any other questions? Let me go back because let's see here. I don't care to say that. Let's see here. Go back to chat here. Let me look here. Yeah, so I talked about that for quiz 3. And yeah, okay, so that sounds good. Any other questions then?
I do have a question really quick.
Sure.
Going back to the example from the quiz 3 that you had, did you equate the sum of the moments from step 1 to the moment about point O in step 3? Is that what that arrow represented?
Yes.
Okay, thank you.
Yep. Mm-hmm. Good. Okay. Other questions? And throw it in the chat if you want to. Can we go over how to figure out if the components are positive or negative when finding the sum of the moments? Okay. Let me do that. Let me just say that, do this here.
I was looking at it like the one of the homework problems with the concrete plate where the force was only acting in the z direction, and they wanted
Yes.
you to find the coordinate. So I was treating it like that problem where you're moving.
Oh, yeah, that one's different. Yeah, that's different because you've got a third dimension.
Right, I
So,
recognize that as well, but
yeah.
you know, if you take all the forces, they have to be somewhere in that concrete slab, and so visually,
Yes. Yeah, and that's the thing is that when you do equivalent, if you're asking for just as a FYI, if we're asking for an equivalent force, um, it does not have to be on the body. Like if you have a bunch of forces on a body and you replace it with one force and give me the equivalent location, that location could be way off in space somewhere. So it's kind of weird that way, but it's true. It really could be. Whereas when you have that concrete example where you've got like the loading on it and you're trying to find the location of it, that probably is going to be on the body, and it's not going to be some weird spot. It's going to be, it's, it'd be hard to develop a problem that it wasn't. I mean, it would be probably somewhere on the body, for that. So, uh, talking about
I
the
wasn't,
signs.
yeah,
Oh, go ahead. Go ahead.
I wasn't constraining to just the y or x axis. I was just trying to find where, and that's why one of the components didn't seem like it played a part in that problem because it was just never, it made a moment, but it never would really change where it's positioned
Well,
on the X.
well,
I understand what.
basically, going back to the principle of the problem, the principle of the problem is we've got a bunch of loads. And of course, I didn't give you a bunch of loads. I usually only gave you two. I think one of the problems had three loads. You got a bunch of loads. You want to figure out how to replace that loading with just one force. So you can't just add the forces up X, Y, and just say, oh, well, there it is, because you have to know where to put it. And so where you put it has to be the same moment about, oh, whatever, as the original picture. So you have to look at the original. And I think that's the confusion. I talked to email with students. It seemed like they wanted to not even look at the original picture. It's like, well, no. You have to look at the original picture and figure out what the moment is there. Because in order for it to be equivalent, wherever you put this new force has to have the same moment as the old picture, because if it's not equivalent. And so you have to figure out the moments first that you have, and then you add the forces together, x's and y's, and then you go, okay, where do I put this xy force? I have to put it in such a way, whether it's x-axis, y-axis, or wherever, that it has the same moment as the forces that I have in the picture. Because if it's not equivalent. It would be something completely different. You can't just move a force and
Well,
not account for its moment.
yeah. Well, it had the same moment. I just didn't constrain it to one axis.
Okay, yeah. Well, then there are multiple solutions. You're right. There are multiple points where you could have the same moment, but that's why I constrain it to one axis to keep it from not, because then there would be multiple answers. Yeah, yeah. It's a
I
good
have a
point.
question about that as well. If we're
Yeah.
calculating, let's just say, for example, the moment about the origin, and there is a force that is coming off of the X or Y axis, either one.
Yeah.
So will there be a component that you do not calculate since it is on one of those axes that the
Yes.
moment lies
Yeah,
on?
there'd have to be. Yes.
There have to be.
If you
Okay.
have a force on the X or Y axis, no matter what its direction, it will always have one of the components that goes through the origin. Yeah, it has to. So, and then would always have another component that wouldn't go through the origin unless that force was on the origin itself.
Right.
Then it wouldn't go through the origin with the other component, and there would always be one. But yes, once you break up a force into components, then it's almost easier. Like, I'll tell you how I visualize these problems. I'll just tell you, when I look at a two-dimensional problem and I see any force that's not purely X or purely Y, I immediately break it up into components. Immediately. I don't even think about it. I go right into drawing components for it because I know that that's going to help me see things. So as soon as I see an angled force, I draw it and go, okay, well, there's my vertical component, there's my horizontal component, one's positive X, positive Y, whatever, and then I write that because then I can just deal, and I almost forget about the other force and I just remember the components because now I've got a bunch of XY components. It's a lot easier to deal with than it is to deal with an angled force. Okay, that's how I do it because I think it's clearer and cleaner to always deal with X's and Y's, not have to deal with angled forces. And same thing in 3D, really. If I have something in 3D, if you break it up, IJK, it's easier to deal with. Now, going back to the question on some of the moments, okay, the key thing here is we just got to remember which one is negative and which one is positive. We've got to remember our signage here, okay? So if we have, let's just say I have this point here, I'm just going to make it up. Oops, not that. Okay, there's A. And then I've got different forces here. This, like this, okay? And like this, okay? Then I've got to ask for each one of those, each one of these forces, how does it create moment about A? So if I look at force 1 here, okay, how does it create moment about A? Well, if you look at it, that force sort of wants to turn like this on A using my counterclockwise is typically positive, and so I would say that's a positive moment from number one there. Okay, positive moment. But then if I'll just label this one number two, right? And then I go here and I go, okay, which one is this turning? Well, it kind of turns A the other way, right? And so, no, sorry, that's doing here. So, that's right. Yeah, that's right. That's negative. Yeah. For a second, I thought I was goofing up, and I was like, I'm not paying. That's clockwise, yes, and then that's negative. And so we typically say counterclockwise positive, clockwise negative. Now this number three up here, right there. Now let me use a different color. Do this. This one here looks like it's turning like this around A, right? So that's also positive. And then it's like, okay, well, those are easy. What about this last one? What about number four? What do I do with four? Okay. Well, what you do with four is, like I said before, you break it up into components, right? What you do is you go, oh, what I really have is two components. I have this and I have this. So now four really becomes two vectors. This vertical vector, right? It looks like it has a positive. It does a positive around A because it's counterclockwise. And then if you look at the horizontal vector here, it's also positive. And so they both, but sometimes they could be, it depends on the situation. One could be positive, one could be negative components. It just depends on how it's drawn. But I like to take, as soon as I see number four there in an angle, I immediately break it up into components. And then I go, okay, well, which component? It makes it more complicated, I guess, because there's two of them instead of one. But, it's still easier that way. It's always easier than dealing with the angled forces. But you've got to remember, is it clockwise or counterclockwise for each? Oh, I don't see that. Any other questions? We're doing good.
And just to confirm, when we're summing those moments, we're doing whatever that component is times the distance away from the
Yes.
moment we're trying to
Yeah.
get the point. Okay.
The horizontal, what we call the perpendicular distance. Yeah.
Yeah.
So, yep.
Cool.
It's the actual moment itself is the force times that perpendicular distance. Yeah. Yep.
If the force is on the minus x direction, for example, I should put like the -3. You know what I mean?
Yeah, here's what I do. I mean, you can get yourself this is a great question, really, because you can get yourself kind of in all sorts of situations where it's like, okay, the force is minus x, but then should I write it that way if I'm multiplying by a distance? I'll tell you what I do, okay, is when I'm just adding forces, right? I'm just adding forces. I'm definitely going to add minuses, pluses. I have to be very careful with the signs. When I'm doing moments and I have, let's say, a force minus x, and then I look at it though, and it actually creates a positive moment. Okay. So I'm sure I could come up with an example of that here. Let me go back to my whiteboard. Let me just do a new one here. So just an example, because this is actually kind of one of those things that can cause issues. I'm getting better with the screen thing. How about that? Okay. All right. So if you've got a force, let's say I'm going to do an example here where it's like, yeah, like this is a force here. And we're going to say, of course, normally we say positive x to the right. Oops. And positive y's here. So if you got something like this, and I've got a point, let's say, here, just like we did before, okay? And we call it point B or whatever, right? And I were to write the moment about B. Okay, and let's just make sure we're clear here. Let's say this distance is here. We'll call this distance D. Okay, it doesn't really matter. I mean, I can make up numbers, I suppose, but let's just call it D. All right. So how would I write that moment? Because you'd say the moment about B is, some people say, well, would you write it like minus F times D? It's like, well, that would imply that the moment is clockwise, but it sure looks counterclockwise, right? So I wouldn't write it like that. What I would write is I would just look at it and go, okay, before I look at the signs, when this is only for moments, what I would do is I would say, does that force F create a clockwise or counterclockwise moment about B? Oh, it's counterclockwise. Okay, so it's positive, and it's just going to be F times D. You know what I mean? Because if you put the minus in there, then you could get yourself all screwed up. Now, when I'm talking about forces, if I'm adding up forces, of course, I'm going to say minus F, plus whatever, right? I'm not going to write, I'm going to write it as negative because it's in the left, it's going left, which is usually minus. I'm going to write it negative for forces. But for moments, if I see it's clearly a positive moment, I'm not going to write negative F there. You could write a negative of a negative. To me, it's just not worth it. So that's how I do it. It's a great question because it can get yourself screwed up.
Yeah, what if the F is on the minus y direction and it's pointing to the positive x? Should I put the distance minus y or something like that? You know what
Oh, yeah. So you mean the other way? Let's say it's below. So if the force F is below the x-axis, should I write? I never write the distance as negative. Never. I always write force times distance, and then I look at the sign completely separate. So I just write positive force, positive distance, and then I look and say, well, what's the sign? Is it negative? Is it clockwise or counterclockwise? I separate all those out. Okay, that's how I do it. Now, this, of course, we're talking about is just two-dimensional. If I'm in 3D, I'm going to use R cross F, and all the signs are going to work out for me. But if I'm in 2 dimensions, then I write force times distance, and then I look at the sign completely separately. Yeah. Any other questions? Thanks for your patience with me. Yeah, go ahead.
I just wanted to ask, I think this has already been asked. If I have a force pointing directly at the moment that it's rotating around, it cancels out when you're summing up the moments, correct?
Yeah, if the force goes right through that point, then it does not create any moment about that point.
Okay.
So yeah, the force still exists, but it doesn't do any moment about the point. It doesn't turn the point. Yeah. Yeah, that's an important point. Like I said, I know it can be frustrating with the multiple choice, no partial credit on the exam, but easier, a lot of time. I never time that's in class. You have, a time, 3 hours plus. I don't give students that much time. I never give students, as easy a time doing here. But and it can be frustrating, I would recommend that you look and find the problems that are easy, do them, get them out of the way, and then time to look very carefully at these harder problems and go over them and make sure you get an answer that matches one of the answers there. Okay. And if you don't, then go back to it later, come back, work on other ones, and then just keep working to try to see if you can figure out and read problems very carefully and go over that homework, because I look very carefully at your homework and I try to fashion problems that are similar to it. I really do. I know maybe you don't feel that way, but I really do. I really do try to do that.
One thing I think, but it's kind of dependent on the limitation of the software that you work with. like
Yeah.
down browser. But I really like
Yes.
how the homework is structured, where if you get something wrong, it tells you you've gotten it wrong, and it just deducts a small percentage of points.
Yes.
I
Yeah.
wouldn't be opposed to that. Just do that in an exam. But like I said,
I
leave
wish.
something for later down. Because
Yeah. I wish there was a way to do that. Yeah. I wish that where you could check, like, try multiple answers and things like that. So, are we going to be testing anything from homework 6? Yes. There'll be one problem that will be similar to homework 6 type problems. I'm going to give you some kind of body and have to some forces, some moments, just like homework 6. So 1 out of the 8 will be similar to homework 6. Um, like I said, I'm going to try to pick the easiest possible problems in a lot of these scenarios. I mean, there might be 1 out of the 8, that I'm gonna go, okay, well, maybe it's a little different. We'll try this. But mostly I'm gonna try to pick really easy problems. The only homework I didn't see anything coming out of it was homework 3. But I did see things coming out of 1, 2, 4, 5, and 6. Particularly homeworks 2 and 4 have a lot of problems coming out of it, and 5 really. Each one of those 2, 4, and 5, I have 2 problems coming out of each one. At least they look like that. Okay. So those are good ones to review. Okay. Okay. Last call for questions. Seems like we've done pretty well. I wondered how many people would be here. 23. That's not bad. I thank everybody. Sorry that we couldn't get together and do this normally. So that would be a lot better. Yeah, you can still email me about homework 6 if you'd like. That's fine. I'm still helping. And I'll email everybody. I'll try to get this recording out to everybody too. And so thank you. Thank you, everybody, for hanging with me. And sorry again for the technical stuff. And I'm working on this, getting this better. So, yeah, thank you. Okay. Well, it sounds like we're good. All right. Thanks, everybody.